Click. There we go. All right, I'm ready to go whenever. All right, guys. Thanks for coming. As you can see, the title of my presentation is "Do I Stay or Do I Go, Lang?" My name is John Games. I'm an HIR Shepherd, HR5. If you guys don't know, you probably do. And I'm going to be talking to you today about a brief discussion on server-side techniques, with a very brief background coming into a bunch of different languages that kind of are covered with server-side frameworks and such, and a little bit more in depth on the two languages that you see here on the screen, Node the runtime, and Go. All right, so let's continue here. If I can actually move this. Excellent. Okay, the cool kids. These are the common suspects, right? These are who you go to when you want to make a server. When you want to make a backend, these are the people you think about, the languages, frameworks, etc. So PHP, obviously, introduced in 1995. These are going to be just a very brief introduction of all these. Introduced in 1995, there's hundreds of millions of websites that use PHP or have it installed. Zynga, Wikipedia, Facebook, they all use this, at least in part, right? And so PHP, no one really wants to use that. It's a bunch of junk. Skip it. All right, so what's next on the list here? JavaScript. This is obviously our bread and butter. We're all went through Hack Reactor, currently going through Hack Reactor. And so Node.js is the way to write server-side JavaScript. And so it's important, it's huge, it's a large community, it's starting to splinter off, but it's still got a lot of followers and a lot of users. I'm gonna dive more into JavaScript later, but next is Java, introduced in 1996. It's massively popular with enterprise work. Java 2 EE is the enterprise edition of Java. Tons and tons and tons of companies use it. It runs on the Java virtual machine. So it has less to do with kind of the setup of the OS and everything like that, which makes it easy to kind of port. Languages are based off its Scala, runs on the JVM, some other languages. Next is ASP.NET. I don't really know anything about this except, nope. It's built in 1992 or 2002. It's built on the CLR, which is a common language runtime, I think, and it means that it can operate with all the .NET languages, commonly used by Microsoft. All right, I don't think I have anything below that. That's the end of my GIFs. All right, next, Ruby. Huge, again, one of the most popular ways to construct a server. Ruby on Rails is the framework that you use, has a bang-in ORM. Active record is awesome, makes life easy. Scaffolding allows a lot of new developers who don't maybe have the proficiency in Ruby to still build out a great database, a great server and backend. Next up, these are kind of the new ones in the realm of server-side languages. Rust just entered their 1.0 stable release. It's developed by Mozilla Research, introduced in 2010. It's a compiled concurrent systems language. And Go, obviously, which is going to be another main part of this talk. And that's developed by Google, a few guys at Google, not like all of Google. But it introduced in 2009. It's a static type language. It's garbage collected, and it's built with a heavy emphasis on concurrency. Okay, so those are the major players. We're going to be diving into more of the choice between JavaScript and Go. And the kind of discussion between these two is going to center around concurrency, right? And so sometimes when people talk about concurrency, you think, yes, I can do tons of different things at the same time, right? But that is actually not what I'm going to be talking about. As you can see from this picture that I stole from someone on Pluralsight, there's a big difference between concurrency and parallelism. And so if you think about concurrency, what it is it's about dealing with a lot of things at once. If you're running a node server, you're getting tons of requests and I/O coming in at different times, and you don't have to deal with each one in order, like as you go down the function execution, right? So as you can see here, this first process starts, the second process starts, the third one, and then once those all finish, we kind of go back to the first one, and it allows things to kind of be dealt with at once, but not simultaneously. So in comparison, parallelism is about doing a lot of things at once, not dealing with, but doing a ton of things at once. And a lot of times people will kind of conflate these two. This is a big thing when Go came out, actually, was that people were like, oh, it's concurrent. That means we can do a lot of massive computations by spreading it out over multiple cores. We can use a lot of clusters to kind of do all these heavy computational intensive services, right? But it's not exactly what it is. Concurrency is more about the structure and the composition of your program. And I'm going to dive more into this with respect to Node and to Go, and compare that to parallelism, which is the execution of these things. And so Node does obviously use both of these. You can spawn a lot of child processes. If you use the require cluster statement, you can kind of start a lot of child forks and child processes and use web workers to allow you to kind of process a lot of information at the same time. This is actually demonstrated using, you can do n queens like this. You can do a ton of different computationally intensive stuff. So those are kind of the examples. Very similar in Golang. You can use the Go max procs keyword to kind of set however many processes you want to run based on the amount of cores that you have in your computer. Cool. So that's what I'm not talking about. I'm not talking about parallel. That's all. That's all you get. No more. Stop here. All right. What's next here? Cool. Node.js. All right. We are all familiar with Node.js. It's a wonderful, wonderful thing. We have used it to build backends. It's an asynchronous event-driven framework. And what that means, think about it in the way of like a jQuery. You have an event, a click, a key up, something like that. And what Node is listening to, or whatever the event-driven framework is listening to, listens to these event emitters and handles each one of those occurrences, right? So if you think about how this is concurrent, another comparison to jQuery is like, if I'm clicking and typing or doing something at the same time, the server having to register some of these doesn't mean that it's blocking you from doing another event, right? So server requests can come in, come out, callbacks can come in, come out based on this asynchronous setup, right? And so Node.js is based on and very similar to Ruby's event machine and Python's Twisted. These are two libraries that are utilized that use a concurrency style called, I believe it's called the reactor pattern. So I'm going to go into that in just a second, but Node.js utilizes an event loop hidden from the users. And if you remember the picture, it's like the circle, it's always checking, it pushes into the event queue, it pushes into the call stack. And so things can kind of keep going, it doesn't block anymore. So let's continue a little bit. The reactor pattern, right? So I'm going to go over this very briefly because it's not the exact way that Node does it, but it's very similar. The reactor, as you can see here, these are nuclear reactors for funsies. A reactor redirects all incoming I/O, which is anything that is a server request, anything to request to get something in or out or change something in a database, and it dispatches those I/O requests to individual handlers, which can take care of them concurrently. Right, so there's multiple processes, and I use processes here and I'm not a thread very loosely, right? So it's not like an actual process on a computer. So different event handlers can handle each of these, and they're all directed from one thread to a reactor, excuse me. Okay, so that's a very basic of Node.js, right? So we all have an understanding. We all know what it is, what it looks like, how to code with it. Let's talk a little bit about the benefits of Node.js, right? The first bullet point, JavaScript on the front and the back end. People are like raving about this. They love JavaScript, all the things, right? I want to hire one developer who can do full stack. He only needs to know one language, that's JavaScript, and he can code all up in my stack, right? He wants to code everywhere. And that's a huge thing for startups who may be lacking in manpower or the ability to hire someone who can code in a PHP or who can code in a Ruby, but can also work in a front-end language like JavaScript. And so this really allows people to read and understand both sides of the stack really easily. And it tends to be slightly overstated by saying people like, oh, you can really reuse code, right? But I don't think I've ever reused server-side code on the front end. I don't think it happens very often. I think that benefit is a little overstated, but it is definitely a benefit to be able to hire a lesser amount of engineers to work with both sides of your stack. This second one is one of the biggest reasons why people don't end up leaving Node.js. There's a ton of packages on packages on packages. NPM is a tremendous way to update your dependencies and to get all the stuff that you need to run, right? If you need something, there's usually a package that can solve whatever your problem is. Now, the problem with this is with such a vast amount of these packages, some of them are kind of left in the dust, right? Some of them don't get updated. You could be pulling a package that hasn't been maintained for a year, 2 years, whatever. And while that's a slight disadvantage to the vast amount that you can actually use, it is something that a lot of Node developers that are making the switch complain about. Also, a slight issue with some of these is that some of them are written in CoffeeScript, right? So if you really want to understand your packages that you're importing, you may have to kind of dive a little deeper into CoffeeScript if you're only familiar with JavaScript. But that is, I think, packages, huge benefit. The third benefit that I can see of just this few that I'm listing here is a lack of threads, right? So Node.js really runs on one thread. It doesn't spin up new threads to execute different things, right? And so the benefit of this is twofold. It simplifies your code. It eliminates any kind of data races where concurrency kind of seeks to modify the same object, right? But it also reduces the amount of computer load that you need, right? Sometimes developers get a little thread happy and can spawn new processes and new threads to take care of things that really don't need it. And the overhead just starts getting bigger and bigger, and you start getting megabytes and megabytes of new threads being spun, and more dynos being taken for your Heroku, whatever, and so that's one of the benefits, is that your code is simpler. There's no threads to mess around with, but you still have the ability to go to the low level of inputs and outputs, TCP streams. You can really do a lot of that. So there's the benefits with eliminating a lot of the kind of costs of being able to use threads. All right, next slide. Drawbacks. The pyramid of doom, right? Everyone hates callback hell. I hate it. You hate it. I'm going to put words in your mouth. The pyramid of doom obviously occurs when this happens. This is just a gibberish function that I found online. But you can see that this pyramid here kind of occurs. There's a triangle. It's messy. Callbacks take callbacks, and there's callbacks and callbacks and callbacks. I'll reuse my previous packages meme. And so this can get tedious, right? And so the problem with this is that sometimes errors can escape you when you're using callbacks. And so an error, when you're 16 callbacks deep and an error occurs on level 13, and you're like, I have no idea when that happened, where it happened, or why it happened, but my data is still coming through because nothing is checking this error. That's a combination of bad developing and also a limitation on how easy it is to deal with errors in Node. And so how does Node kind of bounce back from this? And well, that's through the development of promises, right? And so in a callback, you pass a callback to a function. That callback gets executed once the original function is done. And so compared with promises, a promise will return before completion, but the value of that promise is yet to be determined, right? So it could be an error or it could pass. And so what this does is really linearize your code. Now, this is a huge benefit. Promises on their own carry a lot of complexity. And so it's kind of, excuse me, I don't really want to say it's a hack to fix this callback pattern, but it's definitely not a perfect solution to it, right? So I'm going to go back up here and go to the next one. Low-level interfaces introduces some technical challenge. Node is very close to the I/O process. If you've if you have written Node for a basic server, it takes a ton of code, boilerplate, everything to kind of receive and do things correctly, right? And so this is why people tend to abstract over Node. So Express is extremely popular. Sales will abstract even further on top of Express, so you can deal with databases in an even easier manner. And so that's another kind of drawback of Node that's kind of developer centric. It really has to do with kind of your preferences. The next thing is scaling, and I put a question mark here because this is kind of a topic of conflict between developers online. If you look up can Node scale, you're going to get yeses and you're going to get nos and you're going to get maybes. And a lot of times this really boils down to the fact that the concurrency pattern that Node uses cannot handle computationally expensive processes very quickly, right? So I/O is always going to take a long time, and when it's extremely computationally necessary, it's going to slow down, and there's really very little way to kind of deal with that until Node starts coming out with a little better ways to handle it, which it currently is. They're thinking of new ways, and I think they're doing a lot of new things to kind of improve the speed of Node. But this is one of the critiques of Node currently. All right, so next, Go. This is a cool language, right? It was developed by 3 guys at Google originally. Rob Pike is one of them, who has a history with Erlang and some other really, really concurrent languages. And so it's a systems level language, right? And so that means it doesn't run, it's not a scripted language. It doesn't run with anything. It can just be straight compiled and then run as a binary. And so it's kind of it's true that it is a systems level language, but really it's made for servers, it's made for kind of web stuff, because you don't have the control of things like the lifetimes of your variable. It's garbage collected. You don't have that really low level control of things that you would want to optimize things at a systems level. So while it is a systems level language, it's mostly used at a little bit higher of a level. And when these 3 developers came out with Go, and when they introduced it, when they were developing it, they really wanted to solve this problem of data races. They wanted concurrency to be a central pillar in Go. And so that's how they built it. They built it really focusing on speed and concurrency. And Go is really, really getting more popular, more and more popular. Of course, it has the Google name behind it. So people are using it. People are interested in it because it has that Google name. And if you Google, well, that was interesting. If you Google transitioning to Go from any language, you're going to get a lot of comparisons between Go and Java and Go and Node, Go and Ruby, and all those kind of comparisons, and how people are really kind of transitioning to Go as a backend language. Boom. Communicating sequential processes. I really wanted to use this header just because it seemed cool, and this was a three-word topic. So communicating sequential processes is also known as the actor model. Like I was talking about with callbacks for Node, this is how Go deals with concurrency, right? And so as I mentioned, Rob Pike kind of had a huge hand in developing Go, and he also worked a lot with Erlang, which is one of the more famous languages to deal with concurrency, right? And so this is how Erlang dealt with concurrency. And as I mentioned, it's called the actor model often. And what this means is that there's actors, right? So imagine 2 actors. These are your functions. These are the ones that do something with the data, right? And so while they're doing something with data, they're also passing messages. And so I'm gonna go into this deeper in a second with actual code. But it's messages passed between actors. And once a message is passed between an actor, the sender no longer has access to it, right? So once the sender has sent it, it is fully controlled by the receiver, and the sender can no longer manipulate that data, which really makes for memory isolation, which is a huge part of Go. It allows for safety and lack of data races. Also, this communicating sequential processes way of doing concurrency really allows for actors to be completely decoupled. The functions have no need or desire to know about each other. All they need to do is pass something in and pass something out, and a way to send it and a way to receive it. And so I'm going to show you a little bit more concrete of that. Some of the disadvantages of this, though, it's complicated if you've never seen it. It's hard to get a mental model of what exactly is going on. And the traceability gets a little bit complicated once you kind of get deeper into passing around values. So the benefits of Go, simple built-in coroutines, and they're called Go routines, right? So why this is a benefit is that they introduce it right off the bat. Any introductory text is going to cover Go routines. And it's a really simple way to run functions asynchronously and concurrently, excuse me. And so while this may seem super low level, kind of running these things concurrently with a primitive, it's not as low level as you think, because Go doesn't give you easy access to threads, right? So when you run a Go routine, you're not actually spawning a new real thread. What you're spawning is called a green thread or a virtual thread, which takes a lot less of the call stack space, and is really easy to control, small amounts of size, but can grow if necessary. Let me see if I have an example. Okay, cool. So here's a really dumb example of a concurrency primitive. And you're gonna see it right below this func main here. It says go say world. So if you attach go as a prefix to any function call, what it's gonna do is run that in its own virtual thread. And so you can see below is the hello gets executed first, sleeps for a bit based on this line right below the for loop here, and then world executes, and those are going to alternate every 10 or what is it, tenth of a second or something like that. So you can see that it's really easy to kind of get started with using these concurrent primitives, but they're still abstracting some of the detail away from you. So next, as I mentioned, passing these messages, we use a thing called channels, and you kind of instantiate these channels here with C make chan int. So you're going to make a channel that accepts an int into it, and these arrows show that you're sending in data into these channels. So here, this sum is getting sent into this channel, and here in the main function, you're receiving what's get passed in by sum, and you're storing it in variables x and y. So this is just a very basic examples of the actor model with Go. Next benefit, built-in testing. If you've ever tried to test Node, there's like Mocha and Chai and Jasmine and whatever frameworks that you want. All of it's built-in testing package with Go. Makes it easy, simple to test, unit tests, everything you would want to do. Next, it's fast. There's no need to spin up any kind of virtual machine. There's no need to have an environment. A Go instance can spin up almost instantaneously, and it really allows for the scaling of multiple dynos being brought up really, really easily. If you've used Google's App Engine, it's built to really use this with Go, and it allows Go to be very, very quick. So that's another one of the benefits. Drawbacks, the exact opposite of Node, essentially. Dependency is a pain in the butt. What Go does is it pulls things straight from GitHub. That sucks sometimes because GitHub repos can change. Pointers are still a part of Go. It's a little bit complex if you're just starting. That can be difficult. And the ecosystem is not as developed as Node. It's a little, while they're kind of the same age, it's a little bit more scant on the kind of packages that you can find in the standard libraries are a little bit weaker. So getting to the end, looking forward, I mentioned Rust earlier. Mozilla Research is moving forward with developing Rust. It's in a stable release now, and they're working on releasing a web browser using it called Servo. It's one of their big projects that they're working on at Mozilla Research. IO.js is changing directions, the fork of Node. So keep an eye out for that. Ease of development using Google App Engine and managed VMs is huge for deploying apps that need to be variable level of instances that need to be spun up. Go with this next 1.5 should be able to develop an Android application. So you could see even more people working with Go if they can leave Java in order to write these Android applications. And finally, Node.js incorporating generators with ES6 to improve concurrency could be awesome and could really, really help the speed of Node. And but we'll see in the future how that works out. Anyway, thank you. Questions? I have no idea how long that ran, so sorry if that took forever. Thanks, though.